In this lesson, we're going to continue our continuity. We have a couple different rules that we're going to use and some examples eventually. That if you have this two independent functions, right? You have a function f and a function g. If they're continuous at a certain point, so it's continuous at one, then you have all these other properties that are going to happen. So if you have that, you can actually add them together and it would still be continuous. You can take that function and multiply it by something. It's still going to be continuous. You can divide them as long as the denominator is not 0. So like as long as that piece individually might create 0, but once you put it in the denominator, now it's a problem. Okay, so you got to keep that in mind that when you create a fraction, you could subtract them, you can multiply them, and then you can have something to a function or to a power. So in general, as you go through these, you have different kinds of equations, polynomials, which are linears and quadratics and cubics. That doesn't have any breaks in them, right? There's no problems with it at all. So polynomial functions are always going to be continuous everywhere. Where you do start to have problems are the rationals. When you have variables in the denominator, then there's that possibility that the denominator can become 0. And so those are the types of spots that you're looking for to see if it's discontinuous, because just because that has a fraction actually doesn't guarantee you're going to get a 0 on the bottom. But most of the time you do. And so you have highly likely that you're going to have some discontinuity on these types of problems. All right. So if we're looking for what are the values of the function, here it is. So here's your rational. Here's our potential to have 0 in the denominator. Where is the graph continuous? So let's find where the breaks are, and then let's answer the question. So if I'm taking a look at this, I'm going to factor the bottom. Right, I need things that multiply to 12 that add to -7. So I need a 4 and a 3, both being negative. And then the solutions to those are 4 and 3, but they are actually the problems. Those are our domain issues, because if you plug a 4 into this, it makes it a 0, which would make your denominator 0, because 0 times whatever is going to be 0. So you're going to have domain issues at both of these 2 points. It's not asking you to classify or anything like this. It's a very pre-calc kind of a question, algebra 2, college algebra thing. And it's just saying, where is the graph continuous? Well, f of x is continuous at -infinity to 3, and then 3 to 4, and 4 to infinity, which is really the exact same idea as when you list out what's the domain. You're listing out what are the values that are okay, right? So we're kicking out 3, we're kicking out 4, and that's all we're really looking to do. All right, and then one other thing that's going to lead us to some problems that we'll do in the next video is compositions. So compositions are going to be functions within functions, right? And so if you have this function within a function, you can actually try to simplify this. This will kind of help your cause here a little bit of, you can take one of the functions out, right? Because remember that when you're doing a limit at the end of the day, you're plugging in a value. And so it might be easier to take one of the functions out, right? This outside function out, do the limit of the inside function, and then take that value and then plug it in, right? So, so you have that possibility, that option to do something like that, all right? So on the next video, we're going to do a little bit more challenging problems, and we'll see if maybe we can make this a little nicer for ourselves. All right, so we'll do that on the next video.